But the nice thing about this kind of game is people will be actually watching. Oh, I better that on. So, I've lost my thread now. The player will be constantly looking at the screen to make sure that they're tracking properly, that they're playing the game properly. So we can make quite good assumptions about where the face is going to be placing. Okay, can we go back to the... Quite a lot of people using this conference. So, I'm sure you all know what that is. It's sort of given some kind of pattern like this. Try and find the 3D position and orientation of the card. So there was a game brought out about a year or so ago called Eye of Judgment, which used this kind of technology. And we really just looked at what they had done, and we've spent the last couple of years just trying to make it more robust and more accurate. I think one of the things that we found when we started looking at this is we really wanted to move this card around quite freely, and the existing systems just didn't really seem to offer that at the right speed, and they weren't really suited for the PlayStation 3 architecture as well. So we sort of rewrote it. Basic technique: capture a frame, threshold the image, find all the boundaries between the black and white regions, and trace around them and decide are they a quad or not. We then say, well, these markers have typically two quads, one inside another, so we pair them all up, and these give us our potential markers. And then we, so if you look inside the marker here, I don't know if you can see it, but you render the pattern in the center in 4 different orientations, and, well, I'd say, so if the pattern match is good enough, then we say, well, here's our marker, we've got the 4 corner points, so we can calculate the pose. Done. Okay, so things I didn't mention when I spoke to the game developers. Calculating pose, it's not entirely straightforward. We get those points and we use the fact that these are all on a plane to calculate a homography matrix, and we decompose that to get a pose estimation, and then we use that to initialize an uncensored Kalman filter to refine the pose. And obviously in the next detection, if you detect it again next frame, we just carry the filter going. But if we miss a detection for a frame, we reinitialize. Finding the right threshold was very hard. We did try various kind of adaptive threshold techniques, so looking around a local area to sort of judge the right threshold level. But then, of course, as soon as you bring the marker next to something bright, then it doesn't get detected. I mean, obviously, also once you've found the marker, then it's going to be roughly in the same threshold level next time. Okay, so here's the marker, you can see. Okay, I've got a very sharp shadow on me. That's not going to probably go terribly well with that. Okay, so this works at fairly shallow angles. It will sort of flip between being pretty dark and pretty light, nice and quickly. And actually, because it's detecting quads in the image every frame, it doesn't lose it easily either. And if I point it down to the ground, so I'll put the camera take down. So I hope you can see that that's also very stable as well, and that was quite important to us, again, for this kind of accuracy. This is just like a one-slide thing, like where's camera-based gaming going in the future? I think that 3D cameras are going to form a very important part of that. So for those of you that haven't seen them, on the left we've got a picture from an RGB camera, and on the right we've got what we would get from a depth camera. And as you can see, it's a 3D surface instead of a flat image. And obviously this allows us to ignore the background much more easily and find human pose more easily as well. But to be honest, they really require their own whole sort of presentation, so I'm not actually going to talk about them. I think we're more or less near the end. We're at the end. So, I talked about camera-based gaming. We looked at the data that we get from cameras and some techniques for analysing them. We did a little detour about what makes a good input device. And we looked at some more advanced techniques, and then a brief slide on what the future holds. And actually, before I go to the thing that says if anyone's got any questions, I also just want to say a really special thank you to Pierre, who actually came down to London and just set up all of these demos and just get everything connected together so it all works. So thank you very, very much, Pierre.
The question is, even though you said that this gives you a really rich input device, in reality you're doing very similar gestures over and over again. How do you overcome, I guess, the gameplay question? How do you make the game seem different even though you're doing similar gestures every time?
Good question. So how do you make the game different each time even though you're doing similar gestures? So I think one of the examples I showed, for example, using the head tracking and just attaching this, it's quite a simple idea, just attaching this pendulum on the end. That has a surprising amount of depth to it, because even though I've played that so many times, I still feel like I could get a lot better at it. And so, even though the simplest thing, okay, let's see if we can balance it, but it's like, all right, well, what happens if you've got areas of the screen that you're not allowed to hit? Or we suddenly reverse gravity, or we have two people. In fact, one of the designers saw that and said, "Hey, let's make a Conquer game." Sony's involvement in any of that.
There's a company called 3DV that makes one in Israel.
There is a company called 3DV in Israel that makes one, yes.
Yeah, just so you can buy them, do one. They're not cheap, but you can get them. They're not as good as the ones you guys are using, but they're not bad.
Yes, they've come down, depth cameras have come down in price an enormous amount. I think certainly Richard Marx's group was looking at them probably maybe 6 years ago or so, and I think they cost between $30,000 and $40,000 per camera then, and I think now they're, well, much less probably. I don't know exactly, but probably $800.
So what you've shown so far are games that involve fairly coarse, gross movements in which you're moving your head around, your hands around, and you're very expansive, and you're being looked at by a VGA resolution camera that needs to be sold at a relatively low price in 2008. So can you tell us a little bit maybe about what you're thinking about in terms of higher resolutions, higher dynamic range, things that would be low-level technological improvements that might make for more subtle kinds of scope of gameplay?
Okay, let me have a think about this. Gosh, you're asking much harder questions than I got at the Games Conference. So, what we've tended to find, so that the original camera on the PlayStation 2 was very poor quality. It had a lot of compression artifacts, and so we're only able to do quite simplistic things with it. The PlayStation 3 camera is definitely allows us to do a lot more because the image is much clearer. I do wonder actually how much better it will get with higher dynamic range and higher resolution, because it's still the same kinds of problems that start to crop up. It's things like, stark shadows in the background, being mistaken for the foreground, or sort of lighting changes and so on. So increased resolution really is probably just going to let us do things a bit further away.